Oh, hey there, my friend. It is so good to see you. Welcome back to NorCast Weather School, the show where we take complicated meteorological mumbo-jumbo and translate it into an easy-to-understand lesson for kids and adults of all ages. I'm your friendly neighborhood weatherman, NorEasterNick. Today, we're going to be talking about how a shallow layer of warm air can have big impacts on the weather around us and on sounds that we hear and feel. What? We're going to talk all about temperature inversions. All right, guys, so let's start at the very beginning and try to understand the basics behind what a temperature inversion is and how it forms. On a normal day, this is what our air profile looks like. So you have some warmer air closer to the ground and colder air way up in the atmosphere. So temperature decreases with height. So as you go farther up and you gain altitude, the temperature comes down. That's because our atmospheric pressure also comes down, and generally low pressure equates to cooler temperatures. So this warm air, since it's less dense than cold air, will gradually rise up into the atmosphere, forming clouds high up. As a warm front moves in, that's one of the circumstances that can lead to the development of a temperature inversion. You get this shallow layer of warm air to sandwich in between the cold air aloft and cooler air at the surface. Now, this will prevent any air from rising into the atmosphere, and it creates these stale, stagnant conditions. In our first example of how inversions impact conditions, let's take a gander at how it works with mountains. A shallow layer of cold air gets pushed into the mountain range, and since that air is so dense, it can't rise higher than the terrain. Warm, moist air rises above the colder air as the temperature inversion forms. Rain develops, and as it encounters the colder layer of air, it can form into ice and sleet, making for very dangerous driving conditions. This is very common in those areas. If you live close to the beach, you've fallen victim to temperature inversions a time or two or several hundred over your lifetime. In this scenario, moist air over the ocean cools the air near the surface. The cool air wedges underneath the warm air and creates an inversion over the water. Since a large temperature contrast takes shape, clouds form. And this is part of what we call the marine layer. The inversion can slide on shore, cooling the land and bringing the clouds that were once over the ocean onto the mainland, making for a cool and miserable day eventually. Inversions can have a big impact on the air we breathe. Huh? Well, I mean, if you think about it, it really makes sense. Since the layer of warm air prevents the air at the surface from rising high into the atmosphere and kind of filtering out smog and smoke and other pollutants, they remain locked in. Stale and stagnant air is a result. Staying on the same theme, an inversion can also trap smoke from wildfires close to the ground, further reducing air quality. All right, guys, well, I think that's a wrap. We talked about pretty much everything there. Whoa. Oh, what was that? Oh, duh. How could I possibly forget to talk about the coolest aspect of temperature inversions? Well, that's my opinion, at least. Sonic booms. They occur when a military jet or even a space rock falling into the atmosphere travel faster than the speed of sound. When that happens, a high-pressure cone forms, and on a normal day without a temperature inversion, the sound is able to radiate up into the atmosphere and you don't really feel or hear it. But when the temperature inversion is in place, the sound waves really have nowhere to go, so they reverb between the bottom layer of the inversion and the ground, and that can travel for miles. Let's show you a different way to represent this. Let's suppose there's a plane flying from Connecticut all the way down to Delmarva, and you have an inversion in place. If a sonic boom is created offshore, depending on the orientation of that inversion, you can, in theory, feel that boom all the way to mid-South Jersey or Philadelphia, all the way up into Connecticut and down into portions of Delaware, because the sound waves are bouncing off the inversion and spreading out for miles. This is very common because offshore, that is where the military practices. How cool is that, right? Well, I'd say we talked about some pretty interesting material today, right? I hope you walk away with a better understanding of exactly what a temperature inversion is and what it does to the weather around us. Thank you so much for joining me. Until next time, my friend, keep your eyes to the skies. Hey, thanks so much for watching this video. If you liked what you saw, subscribe to my channel by clicking this button right here. And if you want to learn another lesson from NorCast Weather School, click this video. You can also follow me on all social media platforms. It's at NorEasterNick.